There are two main types of questions that come up in exams that involve sequences and series. These are investments and loan repayments. We'll be taking a look at investments in this video, and in the next video, loan repayments. The following question comes from the 2015 Balcombe Hills trial paper. Let's have a read of it. Karen contributes to a superannuation fund. She contributes $250 at the start of every quarter. The investment pays 8% per annum, compounding quarterly. She continues making contributions for 30 years. It's important that we take a note of the timing of the investments. In this case, they're being made at the start of every quarter. Harder questions can put a twist on the timing of payments. Now let's go through each of the parts. So part A, how much does she contribute altogether? Well, she contributes $250 per quarter. There's 4 quarters in a year, and so for 30 years, the total comes out to $250 times 4 times 30, which gives us $30,000. So this part is kind of unrelated to part C, but we'll make for a cool comparison later on. Now part B, what is the value of her initial $250 investment at the end of 30 years? Well, her first investment is in the bank for 120 quarters by the end of the 30 years. The interest per annum is 8%, so per quarter will be 2%. Using the compound interest formula, we get 250 times 1.02 to the power of 120, and this gives us $2,691.29. So this means that her initial investment will grow to over 10 times its initial value. Now part C, find the total value of her superannuation. So this is the main part of the question, and this is where we'll see how to solve investment questions. So let's recap the scenario. Karen is investing $200 at the beginning of each quarter for 30 years. The way that I like to break these questions down is with a quick diagram. Each of these dollar bills represents each of her investments. Her very first investment will sit in the bank and accrue interest for 120 quarters, and we saw how to calculate its value in part B. Now the next installment is made a quarter later, so it sits in the bank for 1 less quarter, and so for a total of 119 quarters. And its value at the end of 30 years will be given by 250 times 1.02 to the power of 119. The next installment will have 118 quarters to accrue interest, and its value will be given by 250 times 1.02 to the power of 118. And the other terms will continue in this way until the very last one. Now let's come to that very last installment. Remember that this was made at the beginning of the quarter, and Karen wants to know how much it'll be worth at the end of the 30 years. So this last installment gets to sit in the bank for 1 quarter. This is why noting the timing of the investments is really important. So the value of the last installment at the end of the 30 years will be 250 times 1.02 to the power of 1. Now to find the total value of an investment at the end of the 30 years, we have to add together all these values. Now you can see that this forms a geometric series with a common ratio of 1 over 1.02. I actually like to write the terms the other way around to make the calculation easier. So we have 250 times 1.02 plus 250 times 1.02 squared plus 250 times 1.02 to the power of 3, and so on until 250 times 1.02 to the power of 120. Now this series contains exactly the same terms as before, so it's actually exactly the same as before, but writing it this way means that the common ratio is 1.02 instead of 1 over 1.02, making the calculation slightly easier. Now to evaluate this, we plug it into our geometric series formula. Just for reference, the formula is Sn is equal to a times r to the power of n minus 1 divided by r minus 1. Now for our question, we have the first term being 250 times 1.02, r as 1.02, and n as 120. So plugging these into the formula, we get total value is equal to 250 times 1.02 times 1.02 to the power of 120 minus 1 divided by 1.02 minus 1. Plugging this into the calculator, we get $124,505.83. So this means that the $30,000 that Karen initially put in has grown to over 4 times its value over the 30 years.